For example 1, we have to solve this inequality. X divided by 5 is less than or equal to negative 3. So we want to get the variable by itself, x by itself. We were dividing by 5, so we multiply by 5. Of course, we have to multiply both sides by 5. When we multiply the left-hand side by 5, we do get x all by itself. When we multiply the right-hand side by 5, negative 3 becomes negative 15. That symbol in the middle, less than or equal to, stays the same throughout the whole problem. So the solution is x is less than or equal to negative 15. And to graph that, you put the closed dot, because it does say or equal to, at the negative 15, and we're talking about less than, so it'll go off to the left. Notice it looks like a little arrowhead pointing to the left. For example 2, we're solving the inequality using division. This time it was 6x is greater than negative 18. Well, we do want to get x by itself, so we divide both sides by 6. When we divide the left-hand side by 6, we're left with just x. And negative 18 divided by 6 is negative 3. The greater than symbol stays true through the whole problem. So our final solution is x is greater than negative 3. To graph this, we have an open circle because it does not have the or equal to line, so it's just an open circle. And we're talking about the numbers greater than negative 3, so the arrow goes off to the right. You can also look at it as the little greater than symbol looks like an arrowhead pointing off to the right. X is greater than negative 3. Well, now we come to the multiplication and division properties of inequality, case 2. And this is when we multiply or divide each side of the inequality by a negative number. When you divide or multiply each side of an inequality by a negative number, you have to flip the symbol that's in the middle. So if it was a less than symbol, it'll now be a greater than symbol. If it was a greater than or equal to symbol, it'll now be a less than or equal to symbol. We only do that when we multiply both sides by a negative number, or divide both sides by a negative number. One thing that'll trip kids up is when you subtract the same number from both sides, it kind of looks like it's a negative on each side, but it's only if you multiply or divide by a negative number on each side. So let's take a look at their examples. For example 3, solving an inequality using multiplication. The problem was negative 3 over 2n is less than or equal to 6. Remember, when the coefficient is a fraction, what we actually do is multiply both sides of the inequality by the reciprocal, or flip the fraction over. In this case, we'll multiply both sides by negative 2 over 3. Well, the left-hand side does simplify just to n, so that's good. We've isolated the variable. And on the right-hand side, negative 2 over 3 times 6, or times 6 over 1. That'll give us 12 over 3, which is 4, and it's 1 of each, so it's a negative 4. But notice, the symbol in the middle went from less than or equal to, and now it becomes greater than or equal to, because we multiplied both sides by a negative number. So the answer is n is greater than or equal to negative 4. For example 4, now we're solving using division. Same rule. If we divide both sides by a negative number, we also have to flip that symbol in the middle. So now we're solving negative 3z is greater than negative 4.5. We will divide both sides by -3. On the left-hand side, we're left with just z. We flip the symbol. It's no longer greater than. Now it's less than. And -4.5 divided by -3. Same sign, so it's positive. And 4.5 divided by 3 is 1.5. So we have z is less than 1.5. When we graph it, of course, it's an open circle because there was no or equal to line. And the arrow goes off to the left because we're talking about the numbers less than 1.5. And you could look at the less than symbol, and it looks like an arrowhead pointing off to the left.